Hi everybody, so in this video we're going to continue with Chapter 3, Sequences and Series, specifically with 3.2, Arithmetic Sequences. So what is an arithmetic sequence? An example of an arithmetic sequence is something like, say, 2, 5, 8, 11, 14, etc. So let's suppose it's an infinite arithmetic sequence. So what is the characteristic of an arithmetic sequence? Well, that you get the next term by adding a common term or a common difference to each of the terms. So obviously here we're adding 3 to each number, right? We add 3 to 2 to get 5, we add 3 to 5 to get 8, 3 to 8 to get 11, 3 to 11 to get 14, and so forth. So how can we generalize this? Well, let's suppose that the first term in general is a sub 1. So that would be our first term. And we have a common difference of d. So what would be the next term? Well, the next term would be a1 plus d. What would be the term after that? Well, it would be a1 plus d, so plus 2d. And the next one, well, it would be a1 plus 3d, and so forth. So here you see a pattern. So this would be the second term, this would be the third term, this would be the fourth term. So notice that the pattern here is the following. You could say that the nth term is equal to the first term. Notice that they all would have the first term, plus the index. Notice that here the index is 2, and the number multiplying d would be 1. Here the index is 3, the number multiplying d is 2. Here the index is 4, the number multiplying d is 3, and so forth. So that means that this would be the index minus 1, so n minus 1 times the common difference. So in example 3.4, they want us to find the nth term and the 50th term of the sequence 2, 11, 20, 29, 38, 47, etc. Okay, so let's remember that the formula for the nth term would be a sub n is equal to the first term plus the index minus 1 times the common difference. So what's the common difference? That's all we're missing here. Notice that it's increasing by 9, right? So 2 plus 9 is 11, 11 plus 9 is 20, etc. So that means that the nth term is going to be a sub n, first term, which we know here is 2, so 2 plus n minus 1, and in this case times 9, right? That's the common difference. So if we expand this, notice that this is going to be 2 plus 9n minus 9. So the nth term would be 9n minus 7. So 9 times n minus 7 would give us any term, and you can test it. 9 times 1, which is the first term, minus 7 would be 2. 9 times 2 is 18, minus 7 is 11. 9 times 3 is 27, minus 7 is 20, etc. So it generates the sequence. So in order to find the 50th term, all we need to do really is simply plug in 50. So this means that the 50th term is equal to 9 times 50 minus 7. And this is going to equal 443. So next we have example 3.5, and part A says find the recursive, and the explicit forms of the definition of the sequence 13, 8, 3, negative 2. So let's remember that recursive implies using the previous term to find the next term. So notice that here the common difference is a negative number because it's decreasing, and we can see that it's decreasing by 5. So that means that the common difference would be negative 5. Now, the recursive way of saying this would be the first term is 13, and the next term, or the nth term, is going to be the previous term minus 5. So that would be the recursive form of the definition of the sequence. Then the explicit form is the one we saw before, where a sub n is equal to the first term plus n minus 1 times the common difference. So here we would say first term is 13, so this plus n minus 1, and in this case the common difference is the negative number 5. And then from here we would get 13 minus 5n plus 5. So that means that the explicit form of the sequence is going to be minus 5n plus 18. And we can test that with the values, and it'll work. Some people would prefer to write it as 18 minus 5n. That's preferable, probably. Okay, so part B. So this was part A. Part B says calculate the value of the 25th term. So that's easy. All we have to do is plug that into the explicit form. So A of 25 is going to be 18 minus 5 times 25. So that means 18 minus 125, and that's going to equal negative 107. So now we are in example 3.6, and it says find a definition for the arithmetic sequence whose first term is 5 and fifth term is 11. So they're telling us that the first term is 5 and the fifth term is 11. So we know that the formula is a sub n, or the nth term, is equal to the first term plus n minus 1 times the common difference. So we don't have the common difference. That's something that we have to find. So how can we find it? We can plug the information here and find the common difference. So look, the fifth term is equal to 11, but it's also equal to the first term plus the index of the term minus 1. So in this case, 4 times d. And this is easy to solve because we're going to get that 11 is equal to 5 plus 4d, and then 11 minus 5 is equal to 4d. So that means that 4d is equal to 6. So d is 6 over 4, which is 3/2. So that means that we can generalize saying that the definition for the arithmetic sequence would be 5 plus n minus 1 times 3/2, and then from here we get 5 plus 3/2 n minus 3/2, and then in general the nth term would be 3/2 n plus 7/2. So that's one way of doing it. The other way of doing it would be using the recursive definition, right? So recursively, we could say the first term is equal to 5, and then the nth term is equal to the previous term plus 3/2, which is the common difference. So we have to be careful here because we have to indicate for n greater than 1 when we do the definition in this recursive form. So these would be the two ways to answer question 3.6. So next we have example 3.7, and it says, Susie decides to deposit an initial amount of 1,200 euros into a savings account on January 1st. The account pays 5% simple interest on the initial amount of money. Assuming she does not deposit or withdraw any money, how much money will be in the account at the end of 10 years? So notice that it says 5% simple interest on the initial amount of money. And then she does not deposit or withdraw money, but she's going to get 5% interest per year from the initial 1,200. So that means that we have to find out what is 5% of 1,200. So that would be 1,200 times 0.05, which is equal to 60. So that means that every year she's going to get 60 euros deposited into her account. So let's say that she starts at 0 with 1,200 euros. After the first year, she gets 60 euros, so that means that she will have 1,260. After the second year, she gets another 60 euros, so she's going to have 1,320. After the third year, another 60 euros, so it's going to be 1,380, and so forth. We're not going to calculate the rest by this manner, but we do know that we have the end of year 4, then year 5, 6, 7, 8, 9, and the end of year 10. So why is this important? Because notice that we have to include 0 in the sequence. So 0 is the first term when it's 1,200. That means that we need to know the 11th term because 10 is the 11th term. So remember that for an arithmetic sequence, we have that the nth term is equal to the first term plus the index of the nth term minus 1 times the common difference. So we need to find the 11th term. So that means that we have to do u of 11 is equal to the first term. So this is the first term, 1,200, plus the index, n, right? This is the index. So 11 minus 1 will be 10, times the common difference. So the common difference is 60, because that's what is adding up to the account every year. So this times 60, and we're going to get 1,200 plus 600, and this is in euros, 1,800 euros. So now we'll do example 3.8, and it says, given the sequence whose 50th term is 6, the 51st term is 11, and the 52nd term is 16, find the first term. So let's recall that the formula for the nth term is the nth term equals the first term plus the index minus 1 times the common difference. So notice that we already have here the common difference, because if they're telling us that the 50th term is 6 and that the next term is 11 and that the following term is 16, this is a pattern, right? So notice that there is a difference of 5. That means that the common difference is 5. So let's rewrite that with that information. So we have that the nth term is equal to the first term plus index minus 1 times 5. So what we have to find is this, but notice that we can do something. We can substitute with the information, because notice that here we can use this piece of information. We can say that the 52nd term is equal to the first term plus n, which is the index, remember? So 52 minus 1 times 5. Okay, but we also know what the 52nd term is. It's 16, so that means that this equals 16. So notice that from here we get that the first term plus 51 times 5 is equal to 16. And then that means that the first term plus 255 is equal to 16. Therefore, the first term is going to be 16 minus the 255, and this equals minus 239.